we look at question number 4, which requires us to find the integral of sine of x times sine of 2x times sine of 3x dx. So we need to integrate sine of x times sine of 2x times sine of 3x dx. So let us look at the solution. Now, before we look at the integration of sine of x times sine of 2x times sine of 3x dx, it is very important that we note some of main points that we shall be considering when looking at this integration. Now, it is very important to note from the factor formula that whenever you have cos of A plus cos of B, that it will always be giving you 2 cos of A plus B divided by 2 times cos of A minus B divided by 2. Similarly, if you have cos of any angle minus cos of another angle, then it will always give you an expression of this form. Likewise, for sine of A plus sine of B, where you have 2 sine of A plus B divided by 2 cos of A minus B divided by 2. The same applies for when you have sine of A minus sine of B. Still, you will be getting 2 cos of A plus B divided by 2 sine of A minus B divided by 2. So we get all this from what we call the factor formula in trigonometry. Now, looking at what we are given, we have sine followed by sine. So it means if we have sine followed by sine, we shall think about this expression here, where we have sine of an angle times sine of an angle. So this is the expression which we can easily relate to what we are having here. Meaning that if we need an expression that will help us get sine of x times sine of 2x, then we shall think about getting an expression in the form of cos minus cos. So let us look at how best we can integrate this given expression. Now, from here, we can easily say this is same as having, want to rearrange this such that this is same as sine of 2x times sine of x. Then this one here, I will first of all deal with this. Then I will multiply by sine of 3x dx. Now from here, since I want to relate this with the expression for cos, since I want to relate sine of sine of A plus B divided by 2 sine of A minus B divided by 2 with this expression, so I must create a negative 2. So if I need to create a negative 2, I can say this is same as having negative a half integral of negative 2 sine of 2x sine of x, then multiplied by sine of 3x dx. From there, you realize that negative a half times negative 2, it will still be the 1 which is here. So we have not changed the meaning of this expression. So from here, I will have negative a half integral. We realize that this is now an expression from factor formula. This is an expression for cos of an angle minus cos of another angle here. So if we want to get the angle here, we shall simply get 2x, we add there this x, and we shall have 3x. If we want to get the expression which is here, we shall simply get 2x minus x, which is simply x. So we shall have this, then times sine of 3x dx. So we can easily now expand this such that we have negative a half integral of cos of 3x sine 3x minus cos of x times sine 3x, then into dx. So this is x. So from here, if you want, for example, if you need to get back, if you have cos 3x minus cos of x and you need to get back here, it implies that you will now have negative 2 times sine. You get 3x plus x divided by 2. That will be same as 4x divided by 2. Then sine 3x minus x divided by 2. That is 2x divided by 2. So you realize you will still have the expression which is negative 2 sine of 2x then sine of x. So you realize that these two are equivalent expressions. Now from here, we can easily say this is same as having negative a half integral of cos of 3x then sine of 3x dx. Then minus a half times this will be positive a half integral. I can rearrange this to be sine 3x cos of x dx. So this is what we have, and we can also easily get the equivalent identity of cos 3x sine of 3x. That is from double angles for sine expressions. Now from there, let us continue and have this as negative a half integral. This will be same as sine of 6x, but there must be a 2, so this will be a half. So it will be a half sine 6x dx. So why do we say that? You realize from here, we have cos of 3x sine of 3x. But what is this one equivalent to? We know that from double angles that sine of 2x is actually same as 2 sine of x cos of x, meaning that what we have on the right hand side, the angle on the right hand side is half of the angle on the left hand side, meaning that when we talk about sine of 6x, then we expect to have 2 sine 3x cos of 3x. In other words, if I have only this, then it means sine, if you have only sine 3x cos of 3x, it will be equivalent to having a half sine of 6x. So that's why we are replacing cos of 3x sine of 3x dx with the equivalent identity, which is sine of 6x. But because there should be 2 here, so that's why we are creating a half. So that is what we are having as the equivalent expression. So we have this, but we are adding there the integral. Now from here, we have sine 3x cos of x. So there must be a 2 in the expansion, for which you will be considering factor formula. So in other words, we must create a 2 first. So this was a half, so it means we can create a 2 here. It becomes 2 sine of 3x cos of x. But the moment you create this 2, you must multiply by a half. So this will be a half times 2 sine of 3x cos of x dx. And that one can be easily seen from here. You realize that in the expansion for the factor formula, there must always be a 2. So if the 2 is not there, make sure you create a 2 by multiplying by a half as you create that 2. So that's why we have plus this a half here. Then this one, if we create a 2 here, then we still multiply by a half, such that we don't change the meaning of the given expression. So that is basically what we have done here. And from there, we can easily say now this is negative a quarter integral negative a quarter integral of sine of 6x dx. Then plus this would also be a quarter integral of 2 sine of 3x cos of x dx. So from here we can easily integrate this. This is negative a quarter times, when you integrate sine 6x, so you will get 6 comes as a reciprocal, that is 1 upon 6. But remember that when you integrate sine, you will get negative cos. So you will have negative cos of 6x. So plus we have a quarter, and the equivalent expression of this is 2 sine 3x cos of x. That one from factor formula will be an expression that is involving sine followed by sine. But since we have an angle for sine greater than the angle for cos, then we expect to have our expression which is of the form sine of an angle plus sine of an angle. So from there we can easily say that this one here will be equivalent to sine this angle, add there this will be 4x, plus then it will also be sine of the angle which is here minus the angle which is here, which is 2x dx. So from there we shall have negative a quarter. This is negative, so that will give us a plus, that is plus a quarter, then times 1 upon 6 cos of 6x, then plus this would be a quarter. We can now easily integrate this. When you integrate sine 4x with respect to x, you will get negative a quarter cos of 4x. When you integrate this, you'll get minus a half cos of 2x, then plus c. So from there we can easily realize that a quarter is common, so we can pull out 1 upon 4 into this will remain 1 upon 6 cos of 6x. This is minus a quarter cos of 4x. This is minus a half cos of 2x. Then everything we are adding c. So this one here will be our answer for the given question.
Yeah.